Okay, so for this video, I'll be showing you how to solve an inequality question, right, using the test point method, alright, and also showing you how to solve the hence part of an inequality question, which is usually the second part of the question. Alright, so for this video, I'll be showing the test point method. Alright, if you haven't seen my first video on an inequality question, which I used the complete a square method to solve the inequality, you can click on the link below on the description box. Alright, so let's get started on this video. Alright, this video contains the question which is extracted from the Srjc 2017 JC2 Prelim Paper 1 question 2. Alright, the question states, solve the inequality 2x squared plus 2x minus 1 over x squared plus 2x lesser than or equals to 1. Alright, this is a very simple question. Alright, so for step 1, we will move all functions to one side and make the other side 0. Alright, so in this case, I decided to move the 1 alright, to the LHS. Alright, leaving the RHS 0, so I subtract 1 alright, from 2x squared plus 2x minus 1 over x squared plus 2x, leaving the RHS 0. Very simple. Second step, alright, I will establish a common denominator. Alright, so to do this 1 right here is lacking the x squared plus 2x in its denominator. Alright, so to establish the common denominator of x squared plus 2x, I'll need to multiply the x squared plus 2x to the 1. Alright, giving this function 2x squared plus 2x minus 1, subtract away alright, the whole of x squared plus 2x, and the common denominator is x squared plus 2x. Alright, doing some expansion and simplification, you'll be left with x squared minus 1 alright, over x squared plus 2x lesser than or equals to 0. So now we'll go on to step 3. Step 3, factorize as much as possible. Alright, this is actually very important and it allows you to use your test point method efficiently. Alright, so in the numerator x squared minus 1, you'll be factorized to x minus 1, x plus 1. Very simple. In the denominator x squared plus 2x, right, you'll be factorized into x and x plus 2. Alright, this whole thing lesser than 0. Next thing, we will set up restriction for your x value. Alright, the reason for this restriction is because when the denominator is actually equals to 0, this whole function right here, alright, will become undefined. So we cannot let the denominator be equal to 0. And how do we do that? We cannot let x plus 2 equals to 0, meaning x cannot be equal to 0 and x plus 2 cannot be equal to 0. So the criteria for the restriction is x cannot be equal to 0, x plus 2 cannot be equal to 0, meaning x cannot be equals to negative 2. Okay, so the next step is we will use the test point method to determine the sign of each bracket. Alright, so for all these cannot be equals value, we will put an open dot, meaning alright, the point is actually not included. Whereas for all these numerator, whereas it's actually included in the interval, we will use a solid dot, alright, a whole black dot. Alright, so we will mark out the value x minus 1, we will let all the brackets alright be equals to 0, x minus 1 equals to 0, alright, so x equals to 1. It is actually included, so we use a solid black dot. Alright, x plus 1 equals to 0, x equals to negative 1, alright, it's also included, so we use a solid black dot. X equals to 0, alright, which is right here, alright, it is actually not included, alright, so we will use a open dot. Same thing right here, x plus 2 equals to 0, x equals to negative 2, it is actually not included, so we use a open dot. Alright, so to test out the sign of each interval, alright, we will need to substitute a value alright, in the range. So for right here, the range is, the domain alright, is actually x lesser than negative 2. So we can actually substitute x equals to negative 3 to test to this function right here, right, to this function, to see the value, alright, whether it is actually negative or positive. So after we have substituted in, we found that it's actually a positive value. Alright, then for here, we can actually substitute like negative 1.5 to this thing. Alright, and we found that it's actually negative. Same thing right here, we substitute negative 0.5. We found that it's actually positive. For here, we substitute 0.5. We found it's actually negative. For here, let's say we substitute x equals to 2. Alright, we found it's actually positive. Okay, so do you notice a trend right here? Okay, the trend is that the sign is actually alternating. As you can see, it's plus, minus, and plus. Alright, as I've stated right here, if there are no squares in a factorized form, alright, meaning there are no squares right here, right, no squares, the sign will alternate as shown in this number line right here. However, if there are squares, right, there will be a repeat of sign, which I'll show in a video later. Alright, so next step, we will match the sign to the condition. What is the condition? The condition is lesser than or equals to 0. Alright, so we need to find sign, alright, they are negative. Meaning, alright, so in this number line, you can see that the domain that have negative sign is x greater than negative 2. Alright, this range right here, and lesser than or equals to negative 1. And also this range right here, 0, x greater than 0 or n lesser than and equals to 1. Alright, so very simple. This gives you the answer for this question. Alright, so in the second part of this question, alright, you are asked to solve the inequality 2x squared plus 2 mod x minus 1 over x squared plus 2 mod x lesser than and equals to 1 using the hence approach. What does this mean? This means that you have to make use of the method or the answer in the first part of the question. Alright, so how do we approach this question? The first step, alright, is very general. It's actually notice any similarity and difference, alright, between the first part of the question and the second part of the question. Alright, if you notice carefully, all the coefficients, alright, all these coefficients, they are actually the same, alright, for both parts, as well as the sign. Alright, all these signs, they are show the same. However, there is actually one difference. That is, alright, in the first part of the question, all are x. Alright, they are all x. But in this second part of the question, the x are actually replaced by mod x. But the thing similar to the first part is that the x squared is still x squared. Why? Why is it not mod x squared? Alright, very simple. As you know, it's very obvious. X squared is always positive. Alright, and mod x is also always positive. So, mod x squared is equal to x squared. You don't need to put a mod x squared, it's very ambiguous. Alright, so this thing right here can actually be equals to 2 mod x squared plus 2 mod x minus 1 over mod x squared plus 2 mod x lesser than or equals to n equals to 1. So, in step 2, we do the relevant substitution. We let x equal to mod x. Alright, very simple. Step 3, do the relevant substitution into the solution. Meaning, instead of putting x here, right, we substitute mod x into this thing. Alright, as stated here. Alright, however, when solving, do take note of the criteria for mod x. Alright, mod x should be always greater than or equals to 0. And this domain right here, mod x greater than negative 2 but smaller than and equals to negative 1. This thing means that mod x is actually lesser than 0. Alright, as a result, this thing has no solution. Alright, so let me ask with this one to solve. Alright, so do take note of this recap right here. I've written a recap. If mod x is lesser than a, this means that x is actually greater than negative a but smaller than a. However, if mod x is actually greater than a, this means that x is actually lesser than negative a, or x is actually greater than a. Alright, so in this case, we have mod x greater than negative 2. We have mod x greater than 0. So this means that x can be lesser than 0 or x greater than 0. In other words, x cannot be equal to 0. Alright, and this right here, mod x lesser than or equals to 1. This means that x is actually greater than and equals to negative 1, but smaller than and equals to 1. Right, so if you combine these two together, we get x greater than and equals to negative 1, but smaller than and equals to 1, with the restriction that x cannot be equal to 0. Right, so this marks the end of this Srjc question, a very simple question, and you must score these 5 marks in this question. Alright, it's actually very simple to score.